Hello my dear students, today we are going to continue our lesson about nuclear reaction with radioactive decay. So, what is radioactive decay? Remember that we said in nuclear reactions, nucleus of the atom is changing. Okay, so when the nucleus is changing, we can say also the type of the atom is changing. So radioactive decay is a reaction, is a nuclear reaction which an unstable nucleus can give off energy or particles. Okay, when energy or particles goes out from the nucleus, we can say that there is a nuclear radiation, and this process is called as radioactive decay. So we said that with isotopes, remember, sometimes inside the nucleus there are different types of neutrons. So these different numbers of neutrons. So these different numbers of neutrons can cause one element be unstable. So this unstable nucleus will decay, will lose its neutrons, and in order to form a stable nucleus. So we have three types of decays in terms of radioactive decay, in terms of nuclear reactions. We will see alpha decay, beta decay, and gamma decay. Each of these has different properties and different processes. So we will discuss them one by one in order to understand. In alpha decay, an atom can emit one alpha particle which has 2 protons and 2 neutrons. Okay, this is alpha particle always shown like this, with 2 protons and 2 neutrons. So, as a result of an alpha decay, when this atom is losing its 2 protons and 2 neutrons, it is turning into another element. So here, for example, the radium element is turning into radon. So it is becoming another element. Okay? And this new element always will have less proton and less neutron than the original element, because this one is losing one alpha particle. It can be also considered as helium, which is also another element. So this element is losing its protons and neutrons and turning into 2 different elements. Okay, like what is happening in alpha decay. In beta decay, we have a particle called as beta particle. Again, here this carbon element is releasing energy as a result of radioactive decay and releasing one beta particle, and also it is forming another element. Okay, carbon becoming nitrogen as a result of beta decay when it loses beta particle. These beta particles can be called as positron or electron according to their charge. If it is positive, it is called positron. If it is negative charge, it is called as electron. Positive called as positron, negative called as electron. Don't forget. But both of them can be considered as beta particle. What about gamma decay? In gamma decay, which is different than alpha and beta decay actually, because in gamma decay we are not talking about giving out a particle like alpha particle or beta particle. Instead, in gamma decay we have gamma rays. Okay, Most of the time these gamma decaying happening along with alpha or beta decay, but this gamma rays has really high energy form. So this energy emitted by gamma decay is the highest energy among these radioactive decays. Also, don't forget this gamma radiation has no mass or no charge. But we said that in alpha, for example, this alpha particle has two protons and 2 neutrons. It has a mass. And also in beta decaying we have this beta particle. It has either positive charge as positron or negative charge as electron. Okay, but in gamma we don't have any mass or charge. It is just rays. Okay, so therefore it doesn't form a different element or isotope. As a result of gamma decay, it cannot form a new element, but because it is most of the time forming with alpha and beta decaying, it can form a new element. Okay, let me repeat. As a result of gamma decay, we have gamma rays, and there's a huge energy, high energy formed, but we don't have change in the element. But most of the time this gamma decay happens with beta decaying or alpha decaying. That's why there's a change of element at the same time. Okay, how powerful are they? Not all of them has the same energy. We can say that nuclear energy is really strong. It produces really high amount of energy, but not always the same. So different types of radioactive decay releases different amounts of energy. Particles produced by these three forms of radioactive decay can damage living and non-living matter. So that's why nuclear reactions are really serious reactions that needs to be controlled. Okay, but not all of them can harm anything. Okay, we can separate these from each other, from strongest to weakest. For example, alpha particles can not penetrate deeply, cannot go in deeper, but they can damage living things because they can change the chemical bonds in your cells. But on more, beta particles can also break molecular bonds in cells, and they can cause illnesses. But gamma rays have the greatest power. They can remove electrons from atoms, damage your cells, or change the shape, change the atomic structure of metals. Okay, so if you expose to gamma rays too much, it can cause sickness and cancer. So this is really serious. You can imagine this table, this image, when you are considering the differences between alpha, beta and gamma rays. So let's say there is a radioactive material here, and it is emitting alpha particles, beta particles and gamma rays at the same time. So alpha particles has the largest mass. Okay, they have also they also have largest charge. They have 2 protons and 2 neutrons. Okay, and because they have largest mass, when they are moving and going through matter, they can lose energy easily. So they can't these alpha particles cannot pass through paper or cloth. But beta particles are more smaller. They are only charges like positrons with positive charge or electrons with negative charge. So they can penetrate more than alpha particles. They can pass through paper, but even a thin metal can block beta particles also. Even though they are small, they cannot pass through metals. But gamma rays releases the highest energy between these three. So they can easily pass through any types of matter. Almost all types of matter, I'm sorry. They have high charge, they have high energy, so they can pass through paper, aluminium, or different types of matters. But thick and dense materials like concrete can block them. Okay, for example, when you are if you want to save yourself from nuclear attacks, you need to be under really high thick concrete to just protect yourself from gamma rays, because they are the most harmful nuclear rays, radioactive decays, or what we call as nuclear radiation. Okay, so that's enough for today. If you want to check what we learned, please go back to your book, Module H, Unit 4, Lesson 3, and just revise the pages between 242 and 246. I know these subjects can be little bit tricky for you, so please just check and try to read and understand what we discussed during these videos. Okay, check your notes, try to take notes while I'm speaking, just by pausing the video, and revise your book from your online access. Okay, see you in the next session. Thanks a lot for listening.